We met in the Department of Earth and Environment at Franklin and Marshall College. I had been teaching there for a few years. Bob had been hired as a new faculty member. We began doing field work together.
Yeah, I think you're down to the basal gravel.
His training is in Earth history, geochronology, how to date things and determine the timing of when different events occurred. My training is in landscapes and their history, how landscapes change in response to climate change or human impacts. And then we began dating and we got married, and we've been working together now for several decades. Right here, they've been undercut.
5 tons, somewhere around there.
Hundreds of pounds, is that about right?
Yeah, hundreds of pounds, yeah.
That's amazing, right? I tried to pick one up on a field trip the other day and I couldn't.
There were 2 eureka moments for us. One was, there was a student of Dorothy's who was working on a summer research project, and she came into Dorothy's lab and she described a 20-foot high cut bank, a sediment bank, adjacent to a tiny stream that was barely ankle deep. And as we were asking her, well, what did the sediments look like? And she said, well, they're very fine-grained, horizontally bedded and laminated. And I think Dorothy and I kind of looked at each other simultaneously and we said, well, that sounds like reservoir sediments or pond sediments. And we said, did you see any evidence of an old dam? So we decided the very next day that we were going to go down and take a look at it because this was very intriguing. And we walked maybe 100 yards down, and there was remnants of the old dam. I grew up in Lancaster County, and I knew that these types of dams were probably everywhere in the landscape. It was used to drive an old mill, a water-powered mill. Almost the very next day after that, we went to the Lancaster County Historical Society and found some really amazing 19th century maps that showed in detail where all these old mill dams were.
This is 1852.
There were over 400 of these old mill dams on the streams of Lancaster County. 1 mill dam for every mile to mile and a half of stream length in the entire county.
The height of them matters because the higher the dam, the thicker the stack of sediment in the reservoir behind the dam. Once the dams are gone and they're obsolete, nobody wants a water-powered mill anymore. It takes more than a century to remove all that sediment that had accumulated over 2 centuries. So the valley bottoms that had these hundreds of mill dams lining them in Lancaster County and other counties, every one of those miles of streams has some amount of historic sediment trapped behind some old dam that is now, in most cases, eroding away.
This one is particularly interesting because there is almost 1 foot of bank erosion per year in certain locations on this site. So really significant bank erosion. Some of the banks were almost 6 feet tall. So it was a substantial amount of sediment from a very small watershed.
And when I walked down through the woods and saw during a storm or just immediately after a storm what happens with the stream that had been gouged out, and then if a tree fell, all the detritus that would come down from upstream, it was awful.
She basically reached out to us and said, hey, there's some issues with the stream on my property, what can we do about it?
Indian Run is not a very large stream. It drains into Little Conestoga. Silt goes into suspension easily, and even at relatively low flow, it can move down Indian Run, down Little Conestoga, into the Big Conestoga, and then out to the Susquehanna. At that point, it might make it all the way to the bay pretty quickly. This is a great problem throughout the Chesapeake watershed, that there's so much fine sediment in so many streams draining into the Chesapeake that there's great concern about how to reduce that high sediment load with its associated nutrients attached to it into the bay. Between 2002 and 2004, we met some of the engineers at LandStudies out of Lititz, PA, and they told us about a restoration site on Big Spring Run. There were great amounts of bank erosion, just as there are here in Indian Run. We asked if they could bring out their backhoes and do some trenching so we could try to look under all the historic sediment that we could see in that landscape. LandStudies, meanwhile, had other sites they were working on, and at one of them they suggested, let's just remove the sediment, the historic sediment.
So that trenching at Big Spring Run that we did with LandStudies was that second eureka moment that I referred to early on.
That site became so famous, it was award-winning, many people began coming to see that site. Since that time, many projects like this have been done, and we're amazed to see the potential for uncovering buried wetlands. The original landscape would be at which level then? Right about that line.
When construction begins on one of these sites, one of the first things they do is install a construction entrance and other erosion control facilities. And strategically, one of the biggest parts of the construction plan is water management. So they pumped around, set up a pump around system. They pump from the upstream side to the downstream side to dewater the site. After that, they'll go through and start doing clearing. A lot of the vegetation that's in the access area and the restoration area is going to be cleared from the site. And then we're able to start excavating the legacy sediment out from the project.
Probably prior to all the historic sedimentation that occurred in the valley bottom, there would have been a swale in the valley bottom, a swale with springs seeping out. We can deduce that based on things we see in the valley bottom today.
And so if we go in and remove that legacy sediment, which is the impairment, the sediment that shouldn't be there, it's only 300 years old and it actually buries this 10,000-year-old wetland ecosystem. And wetlands, as we well know, is a very powerful ecosystem for cleaning up water. So the idea is if we can remove that impairment, then we have a really solid basis for aquatic ecosystem restoration.
This particular site, they were able to move the sediment off-site, redistribute that on some farmland. We're trying to reutilize some of the woody debris that's native in those valley bottoms. We're actually going to repurpose those down in this restoration design. Once they hit final grade, then they installed erosion control matting. And they also laid a native seed mix and a temporary seed mix too. One of the real magical pieces of this is that if you look in these sediment records, you can actually find this historical valley bottom. As they're clearing this site, they're working from one end to the other. So you can see we have some large woody debris out in the floodplain. They were able to reinstall some of the woody debris throughout.
The high banks are gone, the high erosion rates are gone, the groundwater is exposed, the black soils are exposed. So you can imagine a swale with forested hill slopes, groundwater bubbling up in springs, cold water, probably a lot of wildlife.
And then they brought in plant material, and that's when the planting began. Some of the plant palette is informed by research that Dr. Walter and Merritts are doing at Franklin and Marshall, where they're actually doing some paleobotanical evaluations of the seed to figure out what was here prior to European settlement.
We find seeds in that dark soil right here at this site. We've pulled seeds from the black soil, and they are sedges, many of them. This would have been from roughly 11,000 years ago until 300 years ago. LandStudies began planting things such as native plants along that newly exposed valley bottom, but in the meantime, many things had begun to grow on their own, and we all joked it was like a chia pet.
We could see for the first time that buried wetland soil that Dorothy referred to earlier went all the way across the valley, from valley margin to valley margin.
Water coming in from groundwater, from upstream surface water, can go overbank and spread across the valley and wet the valley bottom. So you get a lush, wet landscape, a wetland. The groundwater is much colder than surface water, and so we end up with lower water temperatures in the valley bottom. So the habitat's superior, and there's very little erosion.
And one of the prime benefits of wetland ecosystems in general is the ability for these wetlands to process nitrate nitrogen, which is one of the major stream pollutants that's in the watersheds in Lancaster County and regionally. It's often a legacy of fertilizer input going back to the 1950s. So it takes this pollution and turns it into something that makes up the majority of our atmosphere.
Carbon is the currency of life. And so I'm really interested in understanding how carbon accumulates and how it decomposes and gets converted from one form to another in wetlands. They're like a storehouse for carbon, a natural climate change solution, if you want to think about it that way.
The conventional wisdom is that the agricultural practices are the low-cost way to improve water quality. And so the first project that we did was testing that hypothesis, and the results of that study were what really opened my eyes and turned me from a skeptic into a big supporter of this approach. Because what we found is that for sediment and phosphorus, the cost effectiveness of this approach was something like 10 times orders of magnitude more cost effective than the existing low-cost practices. If you want to wisely invest public funds in improving the bay, here's one really important tool in our toolkit to do that.
There are many benefits, but in addition, there's some very real research opportunities. They've even engaged 3 postdoctoral researchers to study the impact of the work that's going on and are on the cutting edge of studying this activity, understanding its impact and its benefits, and helping others, not just in Lancaster County, but throughout historic colonial America and beyond. These projects are going to have an enormously wide reach. I have no doubt whatsoever that the work that's taking place here is extending far beyond Lancaster County and the Commonwealth of Pennsylvania.
And Dorothy and her students and colleagues have been doing this LIDAR analysis where they look at repeat LIDAR imagery, which can measure things on the order of a fraction of an inch in terms of its scale on the landscape.
I'm quite happy with the results, the outcomes at Indian Run. It is probably one of the most beautiful restorations I've seen.
You know, we take many field trips there. Student groups, we take policymakers, government officials, engineers, and one of the things we like to do with them, particularly people who are not familiar with the restoration, we'll take them down to the edge of the restoration, and without knowing anything about it, we'll ask the question, well, what is this ecosystem? And they'll look around and they'll say, well, it's a wetland. And and they'll ask, well, how long do you think this was here? And they look around again and they'll say, well, forever, right?